Very good morning to all of you students. Welcome to the mathematics class. In this session, we will study chapter number 7 of class 12 and the name of chapter is application of derivative. Clear student? The first part of this chapter has been delivered in the group and in this lecture we will discuss the second part of this chapter. In the first part, we have discussed some important topics like approximation, tangents, normals, etc. And in this video we will discuss some important another topics like increasing and decreasing functions, maxima and minima, and application of maxima and minima. Clear? So start student. So the first topic is increasing and decreasing function. So if we have a function and put x is equal to anything in the given function, and after differentiating the function its value is always increases, that means its value becomes more than 0, then the function is increasing, and if f dash x is less than 0 then the function is decreasing. Clear? Okay student. Now you can understand by some examples. So see example number 1. Solve x in bracket x minus 1, x minus 2, x minus 3 is greater than 0. It is an example of inequality. So on solving we get x is equal to 0, 1, 2 and 3. And here all the values of x is greater than 0. That means we can say that for all the values of x the function is increasing. Clear? Here plus minus plus minus plus sign shows that in a particular interval of values the given function is increasing or decreasing. Okay student. Now take another example. In this example given 2x minus 3 upon x minus 2 and x minus 4, where this is less than or equal to 0. So here we cannot put x is equal to 2 or 4 because on putting these values the function is not defined. So we can write here x minus 2 whole up square and x minus 4 whole up square greater than 0, because we know that the square of any function is always greater than 0. So here x belonging to real number, that means on solving it we get 2x minus 3, x minus 2 and x minus 4 is less than or equals to 0. Clear? So on solving it we can write here 2 in bracket x minus 3 by 2, x minus 2 and x minus 4 is less than or equals to 0. So from the above inequality on solving we get here some values like it should not be x equals to minus 3 and x equals to minus 1. So this is the example of an increasing function. Okay students. Now the exercise 7.4 is just depend on the increasing and decreasing function. So if you understand the concept of increasing and decreasing function, then you can easily solve the questions related to this exercise. So this is your homework and solve the questions of this exercise. Clear? Okay students. So this exercise is only for homework. Now student, we will discuss here increasing and decreasing functions continued. So here we not only consider increasing or decreasing function, but we also consider here strictly increasing function. So there is a difference between increasing and decreasing function and strictly increasing function. Now student, there are some conditions. So some theorems are given by which you can understand what is the concept of increasing and decreasing function with strictly. So if f dash x is greater than or equals to 0 for all the values of x belonging to open interval a comma b, then f is increasing in closed interval a comma b. This is the first and important theorem. Now the second theorem is if f dash x is greater than 0 for all the values of x belonging to open interval a comma b, then f is strictly increasing in closed interval a comma b. The second theorem is if f is a function and it is continuous in closed interval a comma b, and derivable in open interval a comma b, then there should be two conditions take place. The first condition is if f dash x is less than or equals to 0 for all values of x belonging to open interval a comma b, then f is decreasing in closed interval a comma b. And the second condition is if f dash x is less than 0 for all the x belonging to open interval a comma b, then f is strictly decreasing in closed interval a comma b. Okay student, take some examples. So the first example is here, prove that the function fx is equal to ax plus b is strictly increasing if a is greater than 0. So here we can write fx is equal to ax plus b, and domain of here function, the domain of function is real number. So we can take any real number, and on the all the real numbers the function is defined. Now take f dash x, that means the differentiation of the function. So it should be a into 1 plus 0, that means a, and it is given that for all a is greater than 0 the function is strictly increasing. That means we can say that the function is strictly increasing for all the real values. Clear? Okay student, now take another example. The next example is prove that the function e to the power 2x is strictly increasing on real number. So fx is equal to e to the power 2x, and domain of function is a real number. So differentiate with respect to x, we get f dash x is equal to e to the power 2x into 2. So for all real values the function is strictly increasing. Clear? Now we will discuss one example of strictly decreasing function. So take fx is equal to 2 upon x plus 5. Here domain should be real number minus 0, because on putting x equals to 0 the function is not defined. That means here the domain will be real number minus 0. Clear? Now differentiate it with respect to x, we get minus 2 upon x square. So here we see that on putting any value of x we get always negative value. That means the function is decreasing here. Clear? Okay student. Now student, on the basis of strictly increasing and decreasing concept, you can solve exercise 7.1 completely. So this is your homework, and you have to complete all the questions, and you have to solve all the questions with method and with concept. If you have any problem, then you can watch the video and solve the examples problem. Clear? Okay students. Now the student, next the topic is maxima and minima. So first of all I want to tell you what is the meaning of maxima and minima, and in which condition we will say that the function is maxima or minima. So if you have a function and the function is defined at any particular value, so on differentiating that function at that particular value, if f dash x is greater than 0, on putting the value of x, then we can say that the function is minima at x equals to the given value. It means that we will find minimum value at the given point, and if f dash x is less than 0, then we will find maximum value, and the function is said to be maxima. Clear? So this is the concept of maxima and minima. Okay students. Now student, now see here, we will solve some questions of maxima and minima. See, find the maximum and minimum values of the function if any, and the first part is fx is equal to 16x square minus 16x plus 28. So we can write it in some way, and after solving, finally if we see here the value of function is greater than or equal to 16 in bracket 0 plus 3 upon 2, and we know that the square of any function is always greater than or equals to 0. It should never be equals to negative. Clear? So therefore the minimum value of the function is 24 and it has no maximum value. Okay student. Now the next example is, see student, the next example is find the maximum and minimum values of the function f given by fx equals to sin x plus cos x. So we can write it under root 2 in bracket 1 upon under root 2 sin x plus 1 upon under root 2 cos x. That means multiplying and dividing by under root 2. Now we know that 1 upon under root 2 is equals to cos 45 and sin 45. So put this value, we can write it under root 2 in bracket under root 2 sin in bracket x plus pi by 4. Now we know that the value of sin x or sin t is always lie between minus 1 to plus 1. So it means that we can write it minus 1 is less than or equals to sin in bracket x plus pi by 4 is greater than or equals to 1 for all real values. So we can see that here minus under root 2 is the minimum value and plus under root 2 is the maximum value of the function. Clear? Okay student. Now find the maximum and minimum values if any of the following functions. Clear? So the function is x plus 1 and values are given minus 1 to plus 1. So differentiate the given function for all x belonging to minus 1 to plus 1. The differentiating function, we get f dash x not equals to 0 for any x belonging to minus 1 to plus 1. Moreover, the given interval is open from both sides, so there are no ends points, hence the given function has neither maximum nor minimum. Clear? Okay student. So student, this is your next exercise 7.6 and you have to solve a question of this exercise, and these questions are very simple and you can easily solve the questions of this exercise because they are simply related to maximum and minimum values. Clear? So this is your homework and you have to solve these questions. Clear? Okay. Now next topic is local maximum and local minimum values. Clear? Now there are two cases arises here at points where the derivative fails to exist. First condition, so in this condition you have to solve first, you will have to take differentiate on the function, and after that you will have to put x equals to c in the given function, and then if f dash x is positive then the function is minimum and f dash x is negative then the function is maximum. Clear? Okay. So the exercise 7.7 is depend on the above examples. So you have to solve exercise 7.1, 7.7 completely, and the 7.7 exercise is depend upon local maximum and minimum values. Then the process is same. First of all, you will take the differentiation of the function. After that, you will equate it equals to 0, so you get the points, means turning point, and after that you put turning point one by one and see that, examine whether f dash x is greater than 0 or less than 0. According to this you can distinguish that the function is maximum or minimum. Clear? Okay, so this is your homework and you have to complete this exercise. Now the last topic of this video is practical problems on maxima and minima. So this is important, and generally a long question is asked from the board examination. Clear? From this exercise and from this topic. So in this topic we will discuss some practical examinations, some practical examples of maxima and minima. For example, example number 1 is find two positive number whose sum is 60 and the product of the square of the other number is maximum. So here given that the sum of two numbers 60, that means if we consider one number is x, then the second number will be 60 minus x. Now the product of the square of first number and second number is maximum, that means the function will be x square in bracket 60 minus x. Now differentiate it, we get minus 3x square plus 120x. Again differentiating, we get minus 6x plus 120. Now equate fx equals to 0, we get x equals to 40. That means if x equals to 40 is the first number, then the second number will be 20, because the sum of two numbers is 60. Clear? So f has local maximum at x equals to 40. Now student, the exercise 7.8 is very important, and its questions are generally asked in the board examination. So I have tick here, and you have to solve these questions which are very important. For example, the first question is important. Now question number 2 is also important. Question number 3 is also important. Okay beta, listen. Now question number 8 and 9, they are most important, and they are also very simple questions. You have to only applying the property of differentiation. So these are the questions which are just depend on the applications problem. Clear? Okay students, now so student, you have to solve the questions of this exercise, because this is very important exercise, and the questions of this exercise are very important according to board examination as well as competitive examination. So this chapter is completed in this video, and there is a homework. You have to complete both part of this chapter, and you have to watch clearly, very carefully, the both part of the videos of this chapter. Clear? And you will have to solve as much as possible questions related to the exercise, and you can also solve questions from other books. So this is your homework, and you have to complete this exercise very clearly. Clear? Okay student, thank you very much.